Hello, good evening, everyone.
Good evening, sir.
Let's wait for another 2 or 3 more minutes for this to join, then we'll start the session.
Sir, what will be discussed?
I would like to keep this as an open session because we already reached at the end of week 10, and week 10 also two sessions has been conducted, right?
Yes, sir.
So I would like to keep this as an open session so you guys can discuss about the doubts that we have studied from week 9 and 10. And if you guys still have some doubts from week 5, 6, 7, 8, that is from the concept of list and dictionary. That is also we can discuss it, but majorly I want to discuss about the graphs which we have discussed in week 9 and there is one more week which is 11th week, and because we don't have 12th week, right? We even if I rush it and complete, there is again in 12th week there will be completely revision session because 12th week is kind of a revision session. We don't have any concepts in 12th week. It's only for the revision. So it's better if you are having any gaps between the concepts that we have studied in week 9 and
Sir,
10 so that we can make
I have
clear.
not gone through the lecture of week 12, but the IIT Madras Institute has been released week 11 and 12 both. So I have not, since I have not gone
दर्शक
through
अगर
the
गलती से
lecture,
भी ये
so
वाले
will
ऑडियोज
I get
डिस्कॉर्ड सुन रहा होगा ना, और अगर किसी ने उसको पता भी है ना,
Sorry,
सो व्हाट.
someone, Dhairi Patel, are you speaking here or to someone?
क्लास चालू हो गया.
I think he is speaking to someone else. I'm muted. Yeah, Rupam was saying something.
Yes, sir. I am telling that since I have not gone through the lecture of week 12. So, is there something on week 12? Means since the institute has released week 12 content.
Yeah, week 12, there are videos that we have released, but those are videos that would give you a quick recap of what we have studied so far in the seat.
Oh, okay, sir. Thank you.
Okay, all right. We can start the session. So, okay. Sorry for the disturbance. I'll start with week 10 activity questions. And if you guys were having any doubts in between, or if you guys wanted to discuss some other concepts, feel free to discuss in this session so that we'll be able to complete week 9 and 10 without any doubts if you guys were having any doubts in week 9 and 10. Because this is very important and this will be carried forward in your Python course because the matrix will again come in your Python course. You'll be studying it. And this is very, very important for your PDSA course understanding also because all those graph concepts which will be again involving in about the matrix, all the graphs are represented as a matrix wherever you study in any of the course if you want to study about the graphs, right? Okay,
Sir?
any specific doubts before we start the session, like before I move into activity?
Hello, sir. Hello, sir. I am audible.
Divyanshu?
Yes,
Divyanshu?
yes, sir.
Are you saying something?
Yes, sir. Am I audible to you?
Yeah, you're audible.
Sir, actually, there is a discrepancy in the evaluation of the quiz too. I wrote it to the support team and they said to post in the Discourse forum, instructor will guide you. So there actually the thing
The
is,
discourse, right?
yeah, but usually no one replied it, so I thought I should ask you here. That's why.
Okay.
So actually the thing is, it has been informed that there is one question which is not considered for the evaluation regarding
I
quiz
know
two.
for which question? The
Either
last question, right? The
yes, yes,
numerical one.
yes, yes. That
I
last.
we have ignored that question from the evaluation. I think we have also replied in some of the posts.
Yeah, but actually the thing is, when I received my marks, it seems to be like they have considered for the evaluation of that question. So marks which I
I
get got
mean,
updated.
are you checking in the scoring tool or in your dashboard?
Yeah, in dashboard only. Dashboard there is the marks which I get is they have considered the evaluation for that question.
Okay. Because we signed it off with the by removing that question in the evaluation. Is it for everyone? Yes, I don't see any issues that came to us like this. What about others?
Modified marks has been given to me.
Divyansh, can you check once by your whether have you got detected it somewhere else?
I actually verified it through the scores from the score checker marks also, and the marks
Be,
which I marks the marks actually which I received in the dashboard, it is matching through it only when we consider the evaluation of that question. I can mail you everything if you want. If you can provide me your mail ID, I can mail you the all things with a screenshot, so you can also verify it.
uh, because this is something that I cannot update a mark. But if you have any discrepancy, let me know. But I'll check with the support team. You can mail it to me to this mail ID.
Okay, sir. So I will mail you
Because
this today with
yeah,
the
because we don't have access to update your marks anything directly in your dashboard, right? We also have to check with the operations team and have to update. So you can mail it to me. I'll check and I'll forward to the ops team because at the end of the day they have to update it. If there is any discrepancy, let me know.
okay, sir. I will mail you everything the issue which I am facing. Okay.
Yeah.
So,
What I,
am I audible?
yeah, Abhay.
So, as the pseudocode for the creating matrices and creating a next dictionary is same, right?
Creating matrices in the nested dictionary. It's
Yes.
almost same because the way we represent it, that is the different, right?
But if we got a question according to that, how we can distinguish which is a matrix and which is a next dictionary?
Uh, I couldn't able to get you. Like you want to distinguish which is a matrix, which is representing a matrix, or which is representing a
Yes,
graph.
that's what.
Uh,
If
yeah.
if we didn't use
So
any procedure such as create matrix or something, how we can distinguish the
yeah,
both?
it's depending upon us, like what we are updating in our matrices. Generally, matrices. I mean, the graphs which we are representing to the matrices. So we represent using one of the option is nested dictionary, and one more option is the nested list. I don't know whether the nested list is also covered in the course or not, but I'll discuss that also. Let me share my screen. Okay. Is my screen visible?
Yes, sir, it is visible.
So generally,
प्याज और मसाले अच्छे
Generally, the matrix which we are saying, we used to represent in a dictionary form, as you said. So this will have a nested dictionary, and each of them will have a node, right? So basically, if I have a 4 node, this will represent basically node 0, node 1, node 2, node. And this inner dictionary will tell you again, these are the node 1, sorry, node 0, node 1, node 2, node, right? And if I put 1, that means there is a edge. I think everyone knows, right, what is mean by edge. So for example, this is node 0, and if I put node 1, and if I mention this as 1, 0 to 1, this edge I can represent as a 1, right?
Yes,
Similarly,
sir.
if there is a edge from node 0 to 2 or 0 to 3, like wherever it is, there is an edge, I can represent that as 1, and remaining part I can represent as a 0, right? And similarly, the same thing for the other nodes. Basically, these are node 1, node 2, node 0. And similarly, you can represent for the other nodes up to all the nodes which you have. This is the matrix representation of the graph using the nested dictionary.
So I think there's some problem with your voice.
Is it all right now? I think.
Yes, sir.
Okay. So this is the form of representation using the matrix using the nested dictionary. Okay. And if I want to represent the same matrix in using a nested list, that is also possible. So what this nested list will do is, it's the same form of representation. I'll keep the number of inner list as same, right? So I'll keep one outer list. Okay. So this will be my outer list. In order to just easily understand, I'll write the list in a line, inner elements as a one line by line. Okay. This is the outer list I have, and this is the inner list I have. So let's say if I have 4 nodes, I will be having 4 inner list. Basically, each of the inner list is element, right? Because it's a list of list. So how can I represent in this form?
With the indexes of these lists.
With the indexes, right? So for example, if I want to index this, I could say this is a 0th row, first row, second row, or third row. Or also I can name it as a node 0 and node 1, node 2, node 3, right? Similarly, I can also say the columns which I am representing, right? Again, this will be indexed for each inner list 0, 1, 2, 3, and each of them represents as a node, right? Yeah, if you look at this graph, this is just a sample graph, right? And here, if you can see there is an edge between 0 to 1. That means in the zeroth, from the zeroth node, in the zeroth node, there is edge, it's going outward and reaches 1. That means I can put 1 in the place of here. So this one represents from this 0 node, there is a path to reach the node 1. Similarly, I can put 1 here. Again, this says, again from 0 node, I can reach other paths I can put. That means there is no path between us and there is no edge. And similarly, if I want to extend further, from this node 1, if I can reach again back to 0, I can rewrite it like this, right? This graph will look like this. Either we
Yes.
can represent like this, or also we can represent like this. Basically, this we can say as undirected graph or bidirected graph.
So
because from
can
0 I can
non-directed graph
go
also
1.
same, right?
Sorry.
Directed and undirected graphs we are discussing, right? In the earlier. Is it the same?
Earlier, I mean, you're talking about in this session, or like you're talking about any previous sessions?
In the previous sessions, we used to discuss directed graph and undirected graphs.
Yeah.
Is this bidirected graph and the undirected graph are the same?
Yeah. Bidirected and undirected are same. So basically, from 1 you can reach 0, and from 0 you can reach 1, right? In basically, you can reach from any other node. That's, you can also call it as a bidirected graph or undirected. Generally, we call it as undirected graph, but there is an alternate way to call that as a bidirected. And this is other way of representing, right? If there is an undirected graph, there don't used to be any arrow in it. And here, if you see, I just put bubble. That means from 0 you can go 1, from 1 you can go 0, right? And if suppose this is the graph, and if arrows are present, you can say directed graph. If arrows are not present, that is a undirected graph. Okay. So if you are able to reach from 1 to 0, so you can put 1 here, because from 1 I'm able to reach 0, but from 1 I'm not able to reach any other node. I can put 0, 0, 0. Again, from 2, am I able to reach any node?
No.
No, right? So simply you can put 0. Again, from 3, even not even put any node here, and if there is no path, you cannot put any nodes, right? That means again put 0. So this is the another way of representing a graph using the matrix form, using the listed list. So you can visualize however you want, but mostly the code focuses on this part, right?
Due to random access.
Yeah. So this is one of the way, and there is also the concepts which we have discussed about this weighted graph.
ప్రొఫెసర్ చెప్తున్నాడా గార్డెన్ జాయిన్ అయిపోవచ్చు గ్రూప్ లోనే
Would you? Okay, so please mute yourself if you guys are not speaking here, so that it don't create any disturbance. So there is also a concept called weighted graph. I think this was been also discussed in the previous session. Yes. Right? Hello. Am I audible?
Yes, sir, you're audible. Can you
Yeah.
repeat it? What the hell?
I'm just asking about, have you guys aware of what is mean by weighted graph?
Like there was a distance associated with a direction. That one?
Yeah.
Yes, sir, we discussed in the last session.
So how can we represent weighted graph using the nested matrix or dictionary?
So suppose there are two nodes. Suppose there are three nodes.
Suppose, let's say from 0 to 1, we have a distance of 50 meter or 100 meter, whatever.
Just
Say put
replacing the one with
that
the
weight.
distance.
Sorry?
Just replace the one with the distance between those points. Replace the one just.
So for this, we can just replace this one with this weighted node. Instead of 1, so how it will change is, instead of zeros and ones, now we'll have either 0 or weights. So that now we will be able to identify if it is not a 0, if there is having some random number, that means it is a weight that it could represent either distance or time, whatever that we want to represent it, right? For example, if this is place A and this is place B, and if it's taking 50 minutes, this is also one of the possible of weight weighted graph. Not only a distance, it could be any metric that we could measure between the two nodes. And similarly, for the matrix, again, instead of ones, zeros and ones, you replace this ones with the weights. And here you could replace with this 50, like similarly. And similarly, you can replace the other places where the ones are there, you can replace with the weighted one. So this is how you can represent a matrix in adjacency, I mean, using a nested dictionary or using the nested list. Right? Any doubts?
No, sir.
So you will have just the direct distance, like plain distance between them.
Sorry, could you repeat?
So instead of 0 and 1 coding, you will have a direct distance. You will take the distance
Yeah,
directly. Okay.
yeah, that means it is a weighted, right? That we call it as a weighted. So your graph has information about what is the metric that we are measuring between two nodes, right? From 0 to 1,
Yeah.
I can say it can take 50 minutes to reach, or 50 meter, or 50 kilometer. But that metric we have to decide when we represent
Okay.
a graph.
Okay.
Okay, any other questions before we move into activity questions?
No, sir.
No. Oh, please try to get your doubts cleared, as I said. And because again, next week, there is a concept we call it as a recursion DFS. So it also extends to this matrix concepts and the graph concepts on. And after that, there will be 1 week of revision session, and there will be a revision session separately for interim also.
Sir,
So yeah,
I actually
yeah.
joined late. So can you give me a basic summary of what have you taught till now?
Uh, we have discussed about how to represent a graph using a matrix form, using the dictionary and the list. That's
Okay.
what we have discussed.
Anything regarding the weighted graphs?
Yeah, also the weighted graphs also we discussed it, and how to represent a weighted graph using this nested dictionary and using this nested list.
Okay. Okay.
Like how?
Can, can you just point me to the weighted graph
Gas resolution
dictionary?
or gas resolution.
So generally, here if you look at it, the zeros and ones are represented, right? If you want to represent any directed graph, and if there is a edge, we used to represent using 0.
Mm-hmm.
Else, sorry, if there is a edge, we used to represent using 1. Else, we used to represent 0, right?
Yeah.
But using this weighted graph, what we do is, suppose there is a distance between the 0th node and first node, and it takes 50 minutes to reach, or 50 kilometers, and whatever the weight we are representing. So instead of zeros and ones, what we used to put is, instead of ones, we directly update the weights.
Okay. 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 Understood.
That
So basically,
that means whenever you access a particular index or particular dictionary,
mm,
and if something is not equal to 0, that means
yeah.
you could say there is some weight.
Understood.
That means that value will represent what is the distance between the two nodes, right?
Yes.
So that is what we were discussing.
Okay. Understood, sir. What about DFS?
DFS will be covering in the upcoming week, which is in 11th week. So I won't be going to 11th week. 11th week has a concept of recursion
Okay.
and DFS.
Got it.
Because since DFS is based on the recursion concept, we will be also discussing the recursion and also DFS.
Okay. Okay.
Any other questions or doubts that you have related to week 9 and 10?
One hop, two hop, if you can come again. Like yesterday, I was going through the lecture. In the one hop is equal to first hop, like that it was saying.
Okay, sure. I think it would be better if I give an example and write a matrix of one of, right? That would be
Okay.
better. Right?
One hop, two hop, you can give an example.
I'll give an example of one of. Two ops, I'll brief it, but you should be able to understand. If you're not able to understand, let me. Okay, let me take some graphs. For example, let me take I. I'll
So
take
is
0,
that
1,
1
2.
half and 2 half is the ending of this week's syllabus, or anything extension is there?
There is no extension to one op and two ops. It's just a concept of one op where it comes
No, what is the
from the
end point
matrix.
of this week? I'm asking.
I mean, the last lecture. Yeah, last lecture is about one op, two ops, and up to n hops, I guess. Yeah.
Okay, so thank you.
So let's look at the nodes, some of the nodes that we have. Let's see, this is goes here, and there is also node E, and this node called E. So see, look at here, this is a directed graph that I'm drawing it. I think this would be better. Yeah. So shall I use a dictionary, nested dictionary one or the list one? Which would be better for you to
You
represent?
can use all the things next to dictionary. So in that way, we can see all the function and working in at one go. Like
Yeah.
how hop work, how that is being created in dictionary, and how
Okay.
that is bifurcated.
So the matrix I'll represent in a nested list form, first of all. So again, this has 5 nodes, so I'll put 5 in a list, right?
So 0 to 4.
Yeah. So this is how we can represent. And in order to easily visualize, I'll also noted what is this. So each row corresponds to nodes, and first is a node A, node B, node C, node D, and node E. And by index, we'll be making it as 1, 0, 2, 3. Similarly, for the same thing, and each column will be represented as node A, B, C, D, and E, and it will represent 0, 4, 2, 3. Okay. Now, can someone tell me to represent this matrix in this form, nested list form? So from A, where are the nodes I'm able to reach it, and where are the edges from node A it's been going? From
From
node
A, we
A, I'll
can
be
reach
able
to
to
B.
D, right? Any other nodes that I can reach it?
After B, you can go to C,
No.
but you
Is
can't go
there
directly from A to C.
yeah, right? So I can put 0 to all the nodes. That means I cannot reach from node A to any other nodes directly. right?
Correct.
So but only to B I can reach it from node. So from B, where can I reach it?
C and D.
C and D. So I'll put 1, 1 in C and D, and remaining I'll put 0. From C, where can I reach it?
E.
Only E, right? So I'll put, sorry. Is there always a problem? Yeah. So it is 1, and remaining is 0. Okay. From D, where can I reach it? Can I reach any node from B?
Nowhere.
Nowhere.
All zero.
So
No, sir.
everything is 0. From E,
You can reach to D and F.
We can reach.
E can reach A as well as D, and remaining are 0. So this is the normal matrix that we use to represent. Okay. So now what I'll do is to represent a one of. So again, I will take the same inner list. So one of matrix is nothing but a derived matrix from the original. Okay. Again, this will represent node A, B, C, D, E in the same way, right? A, B, C, D, E. And this is node A, B, C, D. And this is. Now, what will I do is, in this one now, whether I will be able to reach any other node by using an one intermediate node. That's the question, right? Can I reach to other nodes using one intermediate? So how can we compute this? By visually looking, I think you should be able to find it out, right? So you
First,
could
if we make
see
all the
that
diagonal elements 0,
you could see that you can reach A to C using the one intermediate node. And again, you could see from B I can reach E, and from C I can go A, right? These are some of the one-offs that we can see from our graph. But how can we compute from our existing matrix?
first make all diagonal elements 0.
Diagonal element 0, that's, of course, it's a directed graph, you'll be having 0, right? That's not an issue. So if you want, you can put all those diagonal elements as 0. Yeah. But how can you fill ones? Because now if you look at the graph from A to C, there is a path using one of. right? One hop means you can reach through one intermediate. So from A
Is
to
this
C,
matrix is exactly one half?
ideally it should be one, right? Hello.
Is this matrix is exactly one half or both combined, directly and one half?
Uh, it's both one hop and your original matrix. So that means you will also have wherever it has one, that will also be one, right?
Yes.
So
So in the one hop,
So are you there?
sorry, I lost the connection in between. I'm audible now?
Yes, you're audible.
so I was saying in one hop, you will only mention the edges where there is a one hop. Like from A to C and A to D should only be mentioned as one. That's what you're saying?
Yeah.
And the B we can neglect.
Uh, it's not like neglecting. You are checking whether can I move to some other node uh, by using that B, because B is the node some that is I can reach out directly, right? So using that node, can I reach somewhere? That's the
So this is visually that we are getting like how one hop works. But when you are making it in a pseudocode manner, so how to relate pseudocode with this?
yeah, that's what I'm coming. So when you look this matrix of 0 comma 1, that means here I can represent, sorry, uh, get this basically, or I can represent like this also. Matrix of A to B is 1, right? So basically I just put it in a indexed order. So when you see this as 1, that means there is a direct edge, right? Direct edge from A to B. Now, since you know that there is a path from A to B, can I go somewhere using this B? That's the question. So how can you find it out? You are using the pseudocode as usual, as you said, not looking at the graph. So what you do is you iterate all the nodes again. That is nothing but matrix of B of A, matrix of B of B. Of course, this is a, if it is 1, that means it's a undirected graph. So this will be 0 and self graph. And whether you are able to reach other nodes like B to D and B to E. You just explore. You explore you explore all the nodes through B, because you reach the B node now. And you found out that there is a node between A to B, right? And you are just exploring this as a starting point and ending point some other, right? And if you found anywhere one, like for example here B to C is one, right? And you could see that matrix of AB equal to 1 and matrix of B of C equal to 1. And if this is true, your one hop matrix that I represented using O hop, then you can make it matrix of A C equal to 1, and this is where I am updating to 1. So basically, this could be anything, and this could be anything. But this intermediate node that we are visiting, right, that should be seen. So if I want to represent this in a symbolic form, I can write it like matrix of I comma j equal to 1 and matrix of j of k. If you look at it, this is the node that we have reached it, and this is the node that we are starting it so that we are able to reach another node. So if you are able to find this condition and it is one of, and you could update it matrix of I of k equal to 1. Right?
So for the two hops, like as there is an edge from A to C, so there should be an edge from C to some other node, say D, then only A to D
Yeah,
is visible.
I'll come to that. But now is it clear?
Yeah.
So how we are computing from our original matrix to one of matrix?
You are taking a row and then iterating through the columns.
Basically, you just find wherever it's one. And if you find that one, you take out that ending node and you iterate with all those other nodes. And if you are able to find a one, you update your one of matrix, right? I'm not going through pseudocode that you can anyways look at the lectures, right? And you can able to understand it. And when you are solving the practice session, you will be able to get it. But this is the core concept which you need to understand it, right? I'm giving the intuition. If you look at the pseudocode, you'll be able to understand this process. Okay. I'll update my one of matrix or so this is the process I just got updated, right? So from B, where all else you were able to reach? For example, here you see from matrix AB, you are able to see reach 1, right? From B, I'm able to reach C and also D. So my one of matrix will also update you, right? Getting? Again from B, I kept as usual. So from B, I'm able to reach C. From C, I'm able to reach E, right? You look at it from B to C, and from C to E, I'm able to reach it. So I can also update this as 1, and also you can say verify the same from the matrix also. I'm not even looking at the matrix, I'm looking at my nested matrix, and I'm updated, right? Again, if you look at this B to D, from D, I'm able to reach somewhere. No, right?
Yes.
So I don't need to update anything here. And similarly, this will be 0. I don't need to update. And now if you come to C, and C, this is the only place 1. And from C, are you able to reach somewhere? So basically this says C to E, right? This says C to E. And from E, where are the places you are able to visit? You could see this is A that you're able to visit, and this is D. So I can make it this D and A is 1. And you can verify it, right? From C to E, there is a node, right? From C to A, you can go using this one hop, and also you can go using one hop using C to D, right? Is it clear or confusing?
Sir, it is clear.
Clear, sir.
Okay. Now let's take a D. From D, anyways, I'm not able to reach even a single node, so I don't need to update it because there is no one. All right. From E now, if you look at it, from E, I'm able to reach A, and from A, where can I reach it?
B.
Only B. So there is a path from E to A. From A, I'm able to reach B. So I can update E of B as 1. So this I'll update as 1,
Yeah.
right? And from if you look at E to D, from D again, I'm not able to reach anything, so I don't need to update. So this is your final one-hop matrix. So this one-hop matrix says you are able to reach using at most one intermediate node to any other, right?
Okay.
Is it clear?
Yes.
Yes, sir, it is clear.
Here, what we did is something we did is we assumed it is a not weighted graph, and we made it only zeros and ones in order to explore in the pseudocode also, right? But what if it is a weighted graph? So we can simply check whether it is greater than 0 or not instead of checking for 1. And we can update the same as a weight by adding the weight of AB weight plus BC weight in the one off, right? If it's a weighted matrix, you have to update the weights also. So that weight will be AB of weight and BC of. Is it clear?
Yes, sir.
So no doubts, right? So far. So someone asked how to compute 2 hop. So how can we compute 2 hop from the derived one hop matrix?
Just remove
Any
the
idea?
0 and place 1 if we find any root in this matrix. It will be simple.
Yeah. This you can compute 2 hop. I mean, you can derive 2 hop using this one hop matrix, right? Because this matrix already has one in the place of 1. That means it is able to reach a node using this one intermediate node. If you want to extend it to, you can simply use this once, right? for example, here, if you see, if there is an edge between A to C, that means it is able to reach something, one intermediate node to B, because here it doesn't have information because using this one of matrix. And from, sorry, C, right? Here I'm able to reach. From C, if you look at it, I'm able to reach. What are the nodes that I'm able to reach? And for that, again, you have to look at your routes. From C, you are able to reach E, right? Now, this is a two of matrices. Is it confusing?
No, sir.
So basically the same procedure we are doing it. So while iterating, we are checking is there any direct ones using this one of matrix. Once we find a one, in order to check whether the node is going somewhere else or not, we use that original matrix.
Sir, excuse me, can I ask one thing?
Yeah, sure.
You have constructed one hop matrix. So in one hop matrix, so in the first row at the B position, that is in the first row at B position, that is written 1. So will it be 0 or 1? Because when in the one hop matrix, if it will be 0, then only we can come to know that from A it will be reachable to C and D in one hop. Because if B is assigned as 1, so there will be the confusion also, no? Ki it is one hop
Okay,
or
you are saying whether this node exists or not. If
no,
this
no, no.
represents one,
I'm not.
right?
No, 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 sir. I'm saying what the one hop matrix you have constructed. So in the matrix where after A, B is there in the first row, that is assigned as 1. So if we keep 0 over there uh, in one hop matrix in the first row, sir.
Yeah, I'm getting it. Wherever I put one in the blue color, you want to make it as
0,
zero
yeah.
because
So if it is 0, then I think then it is clear that from A in one hop C is reachable and D is reachable. I think so. It should be like this, or should we keep one only? This I'm asking.
that's again up to us. I think in the course we have both ones, right?
Okay. Because I think if it will be in this form, then it is very much clear. Okay, keep in the one step. It will from A. It will be reachable to C and D.
Mm-hmm. Good. Yeah, okay. I think
What were you
you are
discussing? Sorry, I was a bit offline for a while.
okay. I think you are correct. It should be zero. In the course we are representing it as a zero. Mm, sure. So you are saying this should be zero, right? This is the one you are saying, right? Hello.
Yes, sir. Yes, sir. Yes, sir.
Hey, yeah,
Because
you are correct.
when
As per the course, this is how the one of matrix should represent.
Sir,
So now it's clearly
I think they have considered once there because they have said at most one half, which can include a directed. He is right, but they have considered at most that's why there was one the course.
Yes, sir.
okay. So Okay, I'll just look at the slide once because I'm a little confused whether they in the course they are considering. No. Okay, got it. Yeah, I just looked at this code and slightly got confused. Yeah, it's at most one, so the one should exist. Sorry for the sure. What we are discussing about the two ops, right? Is it clear now how we computed two ops? How we
Yes, sir.
derived to two op matrix? So these are the places that it should be. Right.
Two hop means A to E, like you
E-
are hopping B and C.
Yeah, I mean two intermediates.
Yeah, that's why you're hopping 2 points, two nodes.
Yeah. So basically, from this one op matrix, I don't have any places to write here. Basically, from this A to C, if you are able to see, that is already it says that you are able to reach using the utmost one. And if it is A to C is one, again you go and explore this original matrix or direct matrix. And from C you were able to reach E. That means from A to C, this information is arrived in one of matrices, which I will point it in red color. Okay. So this information is also you got from one of matrix, and this is also from one of matrix, and this is also from one of matrix. It will also indicate arrow. So from where you get right. So this red color arrows, which I newly drawn in my graph. So these are uh, the routes that I have discovered through one hop. If I want to discover a route through the two hop, what I will do, I will directly jump into one hop which I am able to reach, and I will look at some other node whether I can reach through two hops. For example, here from A to C, it's already one hop. From C, if I am reaching any node, that is two hop, right? So that I can represent another color. So this represents two hop. I mean, ideally it should come like this, but if I draw like this, it will be messy. Also, I just wrote a direct graph. Similarly, from C to B, again, there is a path, right? If you look at it using two up. Because from C to A, I'm already able to reach it like this. And again, I can reach through two up matrices. So how I compute using this one up matrices, if I want to write that also in a pseudo form way, I can write it here. So what you have to check is you have take that one of dictionary or matrix that you have computed. You take one of ij, whether equal to 1, and direct of j of k. If this is also equal to 1, to make your 2 of I of k equal to 1. So this is how 2 of matrices can be created or indexes can be created. Is it clear?
But this
Guys,
is
so
one
this
hop. You are hopping J actually. Only one
Uh-huh.
node.
No. I take one of matrix. Okay. This
Acha,
one of
acha,
matrix is I
okay,
comma j means
okay.
it's already
Okay.
hopped one.
Got it. Okay,
So
one hop
assume
and that.
we already hopped one. Already. because this is a one-hop matrix, we already hopped one and we are just hopping one more time using this direction. That is our original matrix. So, is it clear? Similarly, you can hop for 3 more times, 4 more times. Again, you can keep on constructing it, right?
So, sir, two hop means there is a two intermediate node,
Yeah.
but it will eventually
Mac
also contain those nodes where there is just one intermediate node, right? Because
yeah.
the one hop is
Yeah,
already at
it's
most one.
similarly
So,
the same. You can maximum it can contain two intermediate nodes. In between, if it is able to reach using one node or even straight edges also there, that will also be considered.
okay.
So got it. So for two hop, you take a one hop matrix and then we direct. Also for three hop, you will take a two hop matrix and then direct. 2 plus 1. Okay.
So, if I want to two hop, what will be the condition for it?
You should be
I mean,
having one
if I
hop.
want three hop, so
You
if
should
I
be
want to
having two
construct a
hop.
three hop matrix, one hop,
Two hop ij is equal to 1 and direct
two,
jk is equal to
two
1.
hop of ij equal to one and direct of
kj is equal to 1.
sorry jk, right? Because this and this should be same because that's the node we are reaching. So this should be one, and if that is true, we can make it three hop equal to one. Okay. Similarly, you can keep on constructing how many hops you want. Any doubts? Any
So far, so good.
doubts about one hop, two hop, three hop? I hope it is clear. So if you are considering weights, so instead
Sir,
of
can you
checking for one,
once
you should
again
have
say, sir,
you have
what is
to
one hop, two hop, and three hop?
uh, any particular doubts here? Hello.
No, sir.
Any other doubts in the week 10 or 9 before we move to activity question? And then
No, sir.
that
No
would be
doubt.
the last.
Excuse me, sir.
Uh,
So, what are the edge?
Divyansh, you are not audible.
Am I audible now?
Yeah, it's better now.
Sir, I want to know, sir, what is edge labeled graph? In the last slide, there is some big pseudocode representing edge labeled graph. Are those for weighted graphs?
Yeah,
Okay.
basically edge labeled is nothing but if you are labeling some edge, for example, if you are drawing a node from 0 to 1, and this is the edge generally we represent. If you are labeling the edge with some weights, that we also call it as edge labeled.
I have some doubt.
Hmm.
Can I share the screen and something?
Just tell me like where you are having doubt. Sorry.
Okay, just let me if you refer to the pseudocode of one hop, first procedure one hop distance, then bracket direct distance. Then n is equal. If you can explain the pseudocode, like what is happening in the pseudocode, you can refer to the slide of the professor.
For the one hop matrix.
You can take example of one hop, basic example.
Okay, I will take an example. Just let me
Definition wise,
copy that pseudo.
true.
Okay, I'll take a copy of that. Okay. just thinking.
No, there was a line that mentioned one hop distance ij is equal to direct distance ij.
Yeah, I'll come to that. Okay, you want to talk about the distance, not the one-hop matrix that is being constructed.
Yeah, basically I'm confused. Like, why have they so one hop distance is equal to direct distance? How they are directly assigning that?
Okay,
Let me check if I can
but
share the
but
screenshot in the
let
chat.
yeah, okay, just let me know whether this is clear, then I'll go to that. After IJ, we also have this. So this one-hop procedure is same as whatever I did, right? First, we just taking a copy of it. This lane just takes a blind copy of your original matrix, right? And this is the procedure that we check for one-hop. Whether to intermediate node I'm able to reach it or not. If I'm able to reach it, I'm updating a one-hop matrix. So basically, this will take a blind copy, means it will take 0 ones as it is from your original matrix. And if there is a one-off, this will update your one-off in the places of one, basically. So this is clear, right? This one-off just updating as a pseudo.
Oh, this is the code that I'm confused with. Like you are
I
taking a
mean,
copy. Since direct hop is different thing and one hop is different thing.
direct graph is a original matrix, basically. So here, if I say uh, here in this case, this is my directed graph. So what I did, I just taken a copy of this. You can see the blue color ones are the ones which I haven't updated. It's just a copy of that, right?
Yes.
So where I updated the place of ones are the places where I checked for the one off, and that
Okay.
is the place this part is getting updated. This is the condition where it's getting updated, and otherwise it's just taking a wherever it is 1 0, it's taking same as it is.
Okay. So just copying the original matrix.
Yeah, that is what I also did, right? While deriving
Oh,
the one off from my original
got it.
matrix. So that is why I said if you are able to look at the pseudocode, you will be able to understand that. Because if I discuss through this pseudocode and write it something that won't be clearly understand behind the concept, you will intuition will go only for the pseudocode. You won't be able to understand the concept. Why I want to discuss the concept is this concept. It's not only for this course. You will be again studying Python course again. That matrix will be again the PDSA course will go, because the concept should be strong, not just pseudocode, because this codes will be keep on changing from course to course, from language to language, right? Any other doubts that you have would like to discuss, or anyone else?
So what is the use of K?
What is the
Why is K required in a loop?
Oh, this K is the one that's taking for this intermediate. Whether I'm able to reach through this intermediate node from I to J. Basically, from A to C, if there is an intermediate node, whether I'm able to reach this A to C through this intermediate node. In this case, this is K and this is I, this is J. And that is what this if condition is checking, if you look at it. From I to K, I'm able to reach it. From K to J, I'm able to reach it. So I'm making a hop from I to J. Clear? Okay, all right. If no other doubts, we can move to the activity questions. Okay, all right. Okay, let me go to go to CNS proposal complete. Okay, is my screen visible? Can someone confirm is my screen visible or not?
Yes, sir, it's visible.
Okay, I'll just brief through whatever the activity questions are there. Okay, what it's about the concept that we have discussed, but anyways, I'll brief through. Is this one true? Adjacency matrix are always a square matrix. So adjacency matrix is nothing but the nested list one that we have represented. Is it always a square matrix? That means the rows and columns were equal, right? Is it true?
Yes.
False, right? Sorry, adjacency matrix are square matrix. Yeah. And adjacency matrix are always symmetric. Is that true?
False.
Why it is not symmetric and when it will be symmetric?
If it is undirected, it will be symmetric.
If it is undirected, it will be symmetric, right? This is the one. So that is one. And here let's try to construct a table. This is the nodes. I mean, this is the matrix form they have given. And this is a weighted matrix or unweighted graph?
This is
Weighted.
This is weighted one, right? From if you look at this from node A, I can reach to node B and node D. And the weight to reach node A and D is this is 100. This is 300. That means that it represents a distance, I guess, the question. Yeah, it is representing a distance. And from node B, I'm able to reach D. That is again the distance is 100. From node C, I'm able to reach A with distance of 600 and C with the distance of 500. And finally, I'm able to reach from node D to B using 100 again. So why I'm writing in this form is again because this is a weighted graph and also a directed one. So that's why I'm writing and another page that is also. So this is the graph. If we convert the above table into a graph, we'll be obtain a directed graph. Is this true?
False.
False? This is a directed graph, right?
Yeah.
But between B to D, you can go through bi-direction, right? Both the direction.
Only between the B to D. But overall, it's a weighted and directed graph. You look at it. So it should be for all the graphs, and the definition is also given here. No doubts, right? Yeah.
No, sir.
Okay. Then for the next question, how many edges will be there in my graph? How many edges were there?
6
You
edges.
can count it 1, 2, 3, 4,
6.
5, and 6. So exactly 6. And what is the minimum distance of a passenger that has to travel from A to D? So
200.
from A to D, 200, because from B I'll be able to get D, right? So that is 200. And what is the minimum distance passenger has to travel from C to A? 600, right?
600, sir. Both the directions.
No, only there is one direction, right? From C to A. You cannot reach C to A through other path. There is only one path, right?
Okay.
And what is the minimum distance have to travel from D to A? Whether will you be able
We
to
can't
reach first of all
travel.
D to A? Travel, right? So traveling is not possible. Okay. Can we move to next one? I mean, next question.
Yes, sir.
Yes, sir.
So before that, just wait for 2 minutes. Come in 2 minutes, okay? Just wait for the time. Sorry for that, students. Okay, move to activity 10.2. I have to guess this. Consider a graph created in the lecture which represents whether two trains share a common station. And if such common station exists, then a directed edge will be added between the trains and edges. will be labeled with station. Choose the correct statements. Okay. And here in this case, I'll tell you the intuition. I think you have to move back to your lecture and see the cards. That is what it has been done. Because again, it will take time for us to generate a same graph if I move back to the lecture. Or if you guys, someone remember what is the graph that has been created. So we can go ahead with that. So assume an edge is drawn between train A and B, and the train B has in degree point. What does mean by this in degree and out degree? I think we haven't discussed this yet.
In the last
In
lecture, we
degree.
had discussed, I think so.
About in degree and out degree?
Yes, sir.
Okay, fine. Then all wrong. So what are the correct statements? Assuming this is I think okay, 1, 2, 3 is based on this question. I think we won't be able to answer unless we see a graph. Then 1 to 4 is also there. 5 to 7 again. Same graph, I guess. Any doubts that we would like to discuss? It would take again another 15 to 20 minutes if we go and solve this. So what is the assumption that is given here? So if there is an edge from train A to B and this has only in degree 1 means, so B can be reached from only station A, right?
Yes, sir.
So I can say the train A and B share only one common station.
Yes, sir.
And also I can switch from train A to B since there is a match.
Yes, sir.
I think for all this question, we need to look at this graph. Even though it's easy to answer, if you look at it. The passenger travels from 0 to 1 and switches to 1 to 2 from a common station. And which is a common station from which the passenger can switch the train. So basically, we have to check whether this train goes to this using a common station. What is the station that we are able to read? So we just need to look at the graph, or you have to compute the graph using the data set. So in the previous question, what is the maximum number of stations that the passenger can visit? And okay, number of nodes, number of edges, is this graph click? So what is mean by click?
Don't know.
Separate group.
A group of nodes where all the nodes can reach each other, right? Directly.
Yes, sir.
Sir, can you
Yes.
repeat it?
Basically, I can say if there are nodes like A, B, C, and all the nodes can reach everywhere. So basically, from A, I can reach other two nodes. From B, I can reach other two nodes. From C, also, I can reach other two nodes. This forms a click. This is a group of nodes that forms a click. There could be another node called D, but it may not reach all the other nodes. Right?
That means with only 3 we can do it.
Only 3?
This means it should only contain 3 nodes, or it can be containing more nodes also.
More nodes also. Not exactly 3. It can contain more number of nodes also. So basically a click could be a size of 2, 3, 4, anything. It can have a size of 2, 3, 4, and goes on up to n. It's up to us. This is a click of size 3 here, whatever I have drawn. Okay. And it generally works in the undirected graph, because from A again you'll be able to reach B, and from B you'll be able to reach A. That is also there, right? Since it's an undirected graph, you can reach any. Can we move to next one, or any doubts? I'm not solving it. This is easy, and you just need to look at this graph that is being taught in the course of the lectures. I hope you will be able to.
Okay, sir.
Today you will covering the practice assignment?
That was already covered, I guess, in the last session. If not, I'll ask the other instructor to cover the activity questions in the next session, and that would be fine. It's been covered. I remember it's been covered. Okay, let's move to the next one. Yeah, consider a procedure, direct routes that is explained in the lecture. What are the keys of the dictionary and the stations used in the same procedure? So what is true about it?
Second option.
Second option, right? All the stations are which are either a starting point or ending point of any trip. How many keys are there in the dictionary for train 12259? That means how many places that train 12259 can reach? Direct routes. Again, this is also straight from the lecture, or you can look at the cards. So here. Okay. If n is the length of keys of the station, what will be the value of A after the execution of following zone? Here, station index is in the dictionary, which is described in the procedure diagram. And what will be the value of A? Can anyone tell this?
Third option.
Third option. Then finally, this is the, and this is the notation that we have discussed also. If direct I to J is there, that means there is a direct connection from station I to J. And if it is 0, that there is no direct connection, right?
Yes.
So option A and C will be the one. Okay. And for the last one, again, one of direct and n hops are there discussed in the lecture. Again, if value of one hop is 1, then choose the correct answer. So that is what it represent, like 1 of I of j equal to 1 means. So you can reach the station I to j through one station, basically at most one station, right?
Yes.
So here what will be the answer then?
I think option 4.
4. Here it is n plus 1 trains. That means if you're reaching station A to C, considering n is 2 in that case, and it will be 3 trains, right? Maximum 3 trains you could go. Sorry, n is 1. Okay, one hop. Okay, okay, it is generic n hops. So the hop, it's based on the hop. That means it is that you could reach basically using 2 trains for station to 2. Okay, then let's move to the next activity question. Here, consider the procedure labeled direct routes used in the lecture. Labeled direct route means that is a weighted graph. Okay, that means which edges are labeled with some weights. So what does the store in it the matrix direct? What does it stores?
Train number as key.
Train dictionary with the train numbers as key, right? Then here, consider a matrix direct dictionary. That means it's a original matrix used in the procedure direct dictionaries. Find the pseudocode to block pseudocode, that is pseudocode block, to store the list of farthest station from X with train connectivity in variable K. What is the farthest station that we could reach it with the distance basically? So for example, if node A connects B, C, D, and what is the another station that I could reach farthest? For example, here this would be 100, this is 200, and this is 200. If there are cases, 2 maximum are there that we are appending it here, right? If you find the maximum and if you find another maximum, you are appending it, else you are updating it to the maximum, just with single element in your list. So we just need to check whether the if condition is correct. So this B should be equal while appending, and this should be less simple. So this is wrong, I guess, because you are checking for maximum. So this should be great. B has been initialized to C. So option D will be correct. Yeah. Yeah, option B will be correct. Any doubts?
No, sir.
And for the let's move to next one then. This is the procedure one of distance finds the minimum distance between the 2 stations which has only direct connection. Is this true?
No, sir.
Right. And the procedure one of distance finds the path between 2 stations which has at most one hop. This is
It can be direct also, so it should be false.
it should be
False.
why it should be false. The procedure one of distance finds a path between two stations which has utmost one. Utmost means it's less than or equal to one, right? It should be true. What the answer says? Let's check what the answer is. False. Oh, it is false. One of distance finds the path between. Okay, it is distance, which has at most one hop. Okay, I thought it's a path. Okay, then it's. Okay. Any other doubts before we wind up this session?
Sir, practice assignment question number 9.
Practice assignment question number.
Week 10.
It has been discussed in last session, right? Practice
Okay,
assignment.
I will say it.
Maybe if it's still not clear, we can discuss it in the next session also.
Yes, sir.
Any other doubts like conceptually that were not clear in week 9 or 10?
Actually, sir, I have a doubt, but not in week 9 or 10. It's a dictionary concept. Can
Okay.
you
Yeah, please.
suppose there is a dictionary with
Your
key.
voice is too low. Can you speak a bit louder?
Okay. Am I audible now?
Yeah, it's better.
Okay. So suppose that there is a dictionary with the keys as ABC and some numerical values like 1, 2, 3 as a value. So suppose if I want to just replace, because we all know how to change the values in a, if there is a dictionary, we can update it or replace it or even assign the value. But suppose we have to just update or replace a key directly without changing its value, then how can we do it?
There is no direct way to do it. You have to delete and basically you cannot update a key. Either you can delete it or you update the value to it. If you want to insert a new key, then you should update a new key with the value and you should delete your old key. That's the thing that you can do. There is no direct method to update a key, even with the programming language.
So basically, deletion is the one thing. After that, we can add the new key. Okay, sir. Okay, sir.
Because keys are something that we are considering as a unique. If you take as a dictionary, it's unique, right?
Yes,
and dictionary is itself a concept that has been arrived from the ash that we'll study in the future courses. So since it's been unique and mapped to specific values, you cannot replace that key uh, and or update. So you cannot replace or update the key. Either you have to recreate it because it doesn't serve that purpose if you are updating a key. Whatever the dictionary that we are studying, right? So we cannot do it.
I mean, if the keys are unique, then why cannot we just directly update with a new unique key? That's what I'm saying.
Yeah, I got your point. That's why I said it's a concept that has came from hashing.
Okay.
It's not a direct concept that we are studying dictionary, that will be studying in the PDSC course, the concept of hash.
Okay.
As far as I know, at least there is no direct method. I haven't seen languages that I have studied, so it's not there, I guess. The one more question is, how can you find a key that you wanted to update?
It is possible to that every adjacency matrix must have skew symmetry.
Every?
Are you sharing a screen?
No, I'm not sharing any.
Okay.
I'm asking
Adjacency
that
matrix.
every adjacency matrix, it is mandatory that it must have symmetry.
No, right? Symmetric means when you will have symmetric means when you have a undirected.
Okay.
So that means from A to B also you can reach it, from B to A also you can reach it. In that way, the matrix will look like symmetric. So if you take
Yeah.
a diagonal one and you can see the upper matrix and lower matrix will be symmetric.
Yeah. Thanks.
Any other doubts? Or else we can wind up the session if you know all this concepts. Okay then. Thank you everyone for joining and have a nice day.
Thank you,
We'll
Sain.
wind up
Thanks.
the session.